Hello and welcome to the 26th episode of our Pharmacy Calculations practice series. Okay, now today's question comes to us from one of our Pharmacy Tech Scholar certification course students. This is very similar to a question we have in one of our exams. We changed it up just a little bit, but the overall concept on how to solve this is going to be the same. So hopefully this will be instructive. But this question states that you receive an order for 500 milliliters of a 10% dextrose solution. You have 70% dextrose solution on hand. How much sterile water will you need to fulfill this order? And we always have to be very careful when we're reading these calculation questions to get down to exactly what they're asking for the answer. So we need to know how much sterile water. And on the PTCE, you'll have 4 multiple choice answers to pick from, but I always encourage our students to try to come up with the answer first and then look at your options, because obviously if you came up with the answer and it's matched in the multiple choice, you know you have the correct answer, or hopefully you have the correct answer. Now I'm going to show you a couple different ways to solve this. First, we're going to do this longhand because I think this explains, the ins and outs of converting to get to the answer. And then we're going to do it via alligation, which is kind of a shortcut, and I'll explain when you can use that and how it applies here. So they're telling us that we need to get to 500 mLs of 10% dextrose. That's what we're compounding. We have 70% dextrose on hand. And we know from the way they're asking the question here at the end that we're going to be compounding that 70% dextrose with sterile water. And we specifically need to figure out how much sterile water is needed as part of that 500 ml solution. So the first step is understanding what percentage means as a concentration. And this is always going to be X number of grams if it's weight based. It could be milliliters if it's volume based, but usually it's going to be weight per volume when we're dealing with solutions. So this is going to be X number of grams per 100 milliliters of solution. So if we have a 10% dextrose solution, this means we're going to have 10 grams of dextrose per 100 milliliters. And with this information, we can figure out how much dextrose we need per 500 milliliters, as in this order. So we can say, if we're going to have a 10% dextrose solution, how many grams, so X grams of dextrose are we going to have per 500 mLs? And when we set up our proportions, I always encourage you to put what you're solving for in the numerator on the right-hand side, and then set up your left-hand side with your known ratio. In this example, it's 10 grams per 100 ml. You have to be careful to keep the units in the same position as the right. So we'll put grams in the numerator, 10 grams per 100 milliliters. And then we can solve this by taking that left-hand side of the equation and solving it. So 10 grams divided by 100, and then cross multiply to the denominator on the right, so times 500 milliliters. And that equals, and I'll bring out my calculator just to double check my work here, 10 divided by 100 times 500. So that's going to be 50 grams of dextrose. So if we need 50 grams total of dextrose in this 500 milliliter solution, we can then backtrack and figure out how much of that is going to be sterile water and how much of that is going to be the 70% dextrose solution. So again, we can set up another proportion and say, okay, if we're going to have 50 grams total of dextrose in our 10% solution, 500 mLs, how many mLs of that 70% dextrose solution are going to provide 50 grams of dextrose? So in this case, what we need to solve for is milliliters of that 70% solution. So how many milliliters of the 70% solution are going to provide us with 50 grams of dextrose when we know that there is 70 grams of dextrose in 100 milliliters? Because remember, this is a 70% solution. And this time we kept the units in the right place, meaning we put milliliters on the top to match the right-hand side. We put grams on the bottom. So we can solve for this again by solving that left-hand side. So that's going to be 100 divided by 70 times 50. And that is going to be 71.4 milliliters. And we know we are going to have 500 milliliters total. 71.4 of that is going to be the 70% dextrose. So the remainder is going to have to be sterile water. So if we solve that out, we get 428.6 milliliters of sterile water as our answer. Now that's kind of long and complicated, so don't get too concerned if you didn't really follow it, but I just wanted to show the breakdown so that you understood, exactly how to get there through converting. Now this is actually a lot easier to solve via alligation. And you can use alligation anytime you're given an order to compound a solution in a percentage strength, given two different percentage strengths of solution on hand. So in this example, we'll set up our alligation, which is always going to show up like a tic-tac-toe diagram. And we put our higher concentration in the upper left and the lower concentration in the lower right. And in this example, sterile water is essentially 0% dextrose solution. So that's kind of a little trick there. Anytime you're dealing with sterile water, that's going to be 0%. Our target percent is going to be right smack dab in the middle of 10%. And now what we do is we take this 70, we subtract 10, and we put the answer in the bottom right. And for the upper right, we take the middle, subtract the bottom left, and we put that answer up here. So that's going to be 10. And this tells us that we're going to have 10 parts of 70% solution for every 60 parts of 0% solution. So if we total that up, we're going to have 70 parts total in this ratio. 10 of those is going to be 70%, 60 of those is going to be 0% or sterile water. And now that we have that information, we can solve for our answer by simply saying, if we have 500 milliliters of total solution and 60 out of 70 of those parts is going to be 0% or sterile water, we just multiply it by that ratio times 60 over 70 equals. And hopefully we get the same answer we got in our longhand explanation. So 500 times 60 divided by 70 equals 428.6 milliliters. So as you can see, this was a lot faster to get to this answer than this entire drawn out breakdown here. So I hope this is helpful. And again, I encourage you to use alligation anytime you have to compound something. It's a percentage solution and you have 2% solutions on hand that are one's greater and one is less than the concentration that you need to compound. If you want help with calculation questions or if you want to see some specific examples, check us out on our Facebook page here. You can send us a message with a request or you can email us at info@pharmacytechscholar.com. And of course, you can just find us on the web at pharmacytechscholar.com.